I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I am your host, Jesse Lawler, excited to bring you our 12th episode of this podcast, devoted entirely to keeping your brain bright-eyed and bushy-tailed and squeaky clean and otherwise totally metaphorically inappropriate, but in a good way. This week's interview is with Dr. Andrew Hill of UCLA. Dr. Hill is somebody who spent 7 years getting his Ph.D. Gosh, those things take a long time. And he was studying neurofeedback and the science behind it during those 7 years and is going to be talking with us all about that. You might remember neurofeedback is something that we actually spoke about on episode 4. So this is kind of a callback to that earlier episode, but going to be delving a little bit more deeply into the science of why it seems to work. I still have not tried neurofeedback myself. I still very much want to kind of give it a day at court myself, but haven't gotten a chance to yet, but hopefully sometime soon. If you hang around until the end of this episode, in this week's ruthless listener retention gimmick, I'm going to tell you why one UK scientist is piping mad and hopping around yelling at the British government for not giving him access to the drugs that he wants. But before you hop on a plane to Britain and start waving your torch and pitchfork and try figuring out how you're going to get a pitchfork through airport security, first you should listen to This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So if you've ever wanted to look inside a brain and see what was going on, boy oh boy has Stanford University come through for you this week. They just published on Wednesday basically sort of an open source recipe on how to turn a brain transparent, like shine a flashlight through it, glass of water, transparent brain, sitting on your desk, looks like a brain, shaped like a brain, squishy, fun consistency of a brain, and yet does not have that annoying, disgusting gray brain color. It's just a clear sort of thing. So this is obviously something you would not want to do to your living brain because you would not survive the process. But if you happen to have a dead brain handy, what you would do is suffuse it with this hydrogel, which they've concocted, which is primarily water, but it has a bunch of chemical components which form sort of a wide lattice structure. Let that set kind of like you would a Jell-O mold, for example. And once that mold is set, you can kind of do a chemical bath on the brain, wash away a bunch of the lipids that would normally make it opaque, and you're left with the other cellular structures in place so you can really see what's going on. So what you would do, for example, is say you've got a mouse. And in fact, a mouse brain is what they did this on. They've done it on part of a human brain, although they say the entire human brain right now is a little bit too large for them to do in its entirety, but they're working that direction and they think they'll get there. So anyway, you've got this theoretical mouse. You want to see what he's thinking about. You put in some cellular markers, some like dyes within his brain that you know those dyes are going to be activated when certain neurons are firing. Let's say you want to see what happens when a mouse is thinking about elephants. So you say elephant to the mouse. Or you show him a picture of an elephant if he doesn't speak English, and then you kill the mouse while that thought is going through its mouse head. So then you do this process on the brain, you turn the brain clear, and you're able to see exactly what neurons were involved in that thought or that behavior or that whatever at the time of death. So pretty powerful stuff. The scientists are essentially all doing backflips because this is a kind of groundbreaking technology and really visualizing what's going on within brains. And they also say this could be done with any other tissue. It's not just brain tissue, but brain tissue is sort of what they're most excited about. But the scientist who invented this says he's got a clear heart on his mantle, a clear liver on his desk, all that stuff. As he said that it took quite a while to figure out the correct process and sort of the heating and cooling cycles and the different chemicals that needed to be applied at what times in these cycles to keep the tissue intact as this whole thing's happening, and that he either burned or dissolved about 100 plus brains in figuring it out. But at this point now it's out there. Scientists all around the world are starting to use this, and it's going to be, I think, very, very beneficial for further brain study and biological study in general.
Smart Drug Smarts.
In news of far less importance, but still kind of awesome for me, picked up a 5-star review this week by Rob Vell, who said, really entertaining. Well, all except for that one episode with the horrible sound quality and that wishy-washy episode. Yeah, that's true. I wish there were only one with horrible sound quality. I think we've actually probably had a couple of them, but anyway, no one to blame for that but me working to make it better. He says, keep it up, man. I'm looking forward to learning more from this podcast. And I am looking forward to learning more in the process of putting together this podcast. So thank you very much, Rob, and thank you for everybody that's given a positive review on this show. I'd like to give a hearty you to the one guy who gave me a 1-star review, but I assume he's probably not listening anymore anyway. With no further ado, let's jump into the heart of this episode, which is the interview with Dr. Andrew Hill of UCLA.
To start off with, you've got the Ph.D. in Cognitive Neuroscience. I would love to hear sort of how you got started in that and what your graduate work in studying attention dealt with exactly.
I started having an interest in cognitive neuroscience quite a long time ago. And spent a long time working in inpatient psych with, acutely mentally ill people. And then I ended up working with developmental populations. And every population I worked with, the question sort of became, okay, well, how can I improve this person's functioning? How can I help? I think I spent a year once teaching a guy to use a fork. I mean, that was my big accomplishment. 1 year working with a developmentally disabled man. And we spent a good year, teaching him to use a fork. And that was, a very small incremental improvement. And I eventually wanted to pursue larger improvements. And I made my way to, working with inpatient acute populations. And then I ended up working, in neurofeedback, ways of changing the brain. And I saw neurofeedback, which is EEG-based biofeedback. I saw it make some pretty profound changes in ADHD and autistic spectrum people. And that really intrigued me, and it also frustrated me a little bit because there was no real clear sense of how it worked. In fact, at the time, this was maybe 10 years ago, there were probably 2 or 3 major schools of neurofeedback with their own ideas about how it worked, their own sort of decision trees and recipe books, if you will, of what protocol to use for what complaint or what brain pattern on a brain map, a QEEG. And so there was these 3 different schools of neurofeedback, and the underlying theories behind them were conflicting. 2 of them could not be true, and yet all 3 of them had, self-reported, but all 3 of them had above 90% efficacy reported by clinicians using the technique. So that really bothered me. It sort of screamed, blind men and an elephant situation. And I went back to school. I had been out of school at that point for about 10 years, and I applied and got in and went to UCLA to pursue literally the question, how does neurofeedback work? What the heck is going on? Because I saw some amazing things, and I saw a lot of subtle stuff too. I became a believer in the technology, and I couldn't figure out how to optimize or how to accelerate it. It's like exercise, so it takes 20 or 30 half-hour sessions of training your brain before you sort of make big shifts that are permanent. And I didn't really like the idea that I couldn't tweak it and optimize it and speed it up and make it work better, because most of the field was operating without the basic fundamental understanding of what actually was happening. They were just sort of being driven by clinical success, which, that's of course the classic research versus clinical question.
Interesting.
And so I, impassioned and inspired by the clinical success, turned my attention back to the research side for, 7 years of a PhD. And most of that was assessing attention, looking at, how do you measure attention? And I used a lot of visual field, tectistoscopic presentations where you're flashing things very quickly to one hemifield or the other to probe attention in one hemisphere at a time. And by restricting output or responses to one hand or the other, you can sort of probe an attention resource within one hemisphere, or you can probe attention resources that require both. So I built a lot of tests like that. I worked with a guy named Eran Zaidel at UCLA, who's a classic laterality scientist. And we, tested some split brain subjects and a lot of undergraduates who, in theory, are normal. Over the time I was doing that, I was sort of refining my understanding of how neurofeedback worked and how the brain can pick up on what we're asking it to do, how to make more or less of a brainwave band or frequency, alpha, beta, theta, etc. And I got some, clues there. Science is always a moving, refining target. So I have some great data and some, good ideas about what's actually happening at the very low level of the human brain being coupled to a feedback paradigm. It's not zapping. I'm sure a lot of your listeners are familiar with neurofeedback, probably more than many audiences. But the one question I get asked a lot by people is, well, I don't want to zap my brain. That sounds dangerous. Is it going to hurt? And in neurofeedback, it's EEG. It's a couple of passive electrodes pasted to your scalp. And then a computer's changing and, making sounds, chimes, spaceships are flying around, whatever. Some stimulus is occurring when your brain trends in the right direction or stays in the right direction in terms of EEG parameters.
Right. And it's not any sort of stimulus that you wouldn't normally be getting when you're listening to music or watching a television screen or, these other things that are part of our everyday lives anyway.
Right. The only thing that's special about the stimulus that you're getting as a reward is that it's yoked to your own physiology in some way. So, it tends to, after you do a few sessions, it tends to feel a little more compelling. The little boring Pac-Man walking around the screen eating dots starts to feel more compelling when his stopping and starting is driven by, your theta amplitude going up and down, for instance.
Interesting.
So, it's very subtle internal states that you end up sort of becoming aware of while training. I do want to say that central biofeedback or training on the brain, neurofeedback, is typically a non-cognitive experience. You don't have to try. And it was actually discovered on cats, and it works on nonverbal, profoundly retarded, or autistic individuals.
If these things are as effective, neurofeedback devices are as effective as some of the claims that one hears, is like, why is this not more pervasive?
Some of my thoughts are scientific, and some of them are cynical and political.
We'll take both kinds.
Right, I figured. Let's roll back to the late 60s. That's about when neurofeedback was discovered. A scientist at UCLA named Barry Sturman, he was an animal-oriented scientist, I think neuroscience, and he was working with cats as his sort of animal in the 60s. And NASA came to him and said, hey, our astronauts are getting woozy and sick when they're exposed to vapors of rocket fuel, hydrazine. We need to figure out what the risk factors are. And so Sturman did a series of experiments looking at dose-dependent response of hydrazine in cats, and found that very reliably they have this dose-response curve where they get, unsteady, ataxic or dizzy, essentially. And then they appear to be nauseous or, uncomfortable. Then they throw up, and eventually it's sort of a, seizure, coma, death kind of response curve. Sturman was working with cats, and he was mapping out this response curve, and for some reason discovered that a subset of his cats refused to have a seizure. Their brains appeared to be much more stable than they should have been, and the dose response curve was shifted to the right, essentially. And that kind of bothered him. He couldn't figure out why one group of cats had this sort of extra stability, and then he remembered that the subjects in an experiment 6 months prior to that, just to do a proof of concept to see if cats could be trained to raise a brainwave frequency for a milk reward. And he was successful and didn't put the cats back in the pool of subjects and didn't think much about it until 6 months later. Those same cats had really stable brains. And that brainwave he had them raise was called SMR, sensory motor rhythm. It's neurologists call it sigma or sleep spindles. And it's a 12 to 15 hertz rhythm in humans. In cats, it's really prominent, which is probably why Sturman went after it. Have you ever seen a cat who's sitting on a windowsill or lying down somewhere, and their body's incredibly relaxed, but their eyes and their attention's incredibly focused?
Yeah.
That combination of quiescent body and activated mind is really the sort of SMR state. And somehow that's what was stabilizing in these cats, and humans produce it in bursts when they're sleeping. It's more of a sleep or integrated rhythm, so to speak. But SMR training became the core of the next 20 years of neurofeedback. And then alpha theta, which is a relaxation format, also came out. And to get back to your question about why is this stuff not more adopted, my first somewhat cynical or even scientific, blend answer is about 1970, there was this big emphasis on all of these relaxation techniques, chilling out, and there was GSR biofeedback and other things sort of showing up on the market. And neurofeedback was just getting popularized, and what was popularized was alpha biofeedback. Now, alpha rhythms they're an idling rhythm to a very large extent. Now, alpha is not one thing. There's at least 4 different types of what I would call alpha in the brain. But stepping back and generalizing, alpha is an idling rhythm. You can think about it like your car is in the driveway. It's running fine, but it's not going anywhere. That's alpha. So when there was all of these pushes and technologies and initial devices in the 70s to get people to do neurofeedback, it was alpha biofeedback. And at most, alpha by itself, training alpha by itself, produces a gentle relaxation state. And that's kind of it. It's like if somebody discovered a new class of drugs and the first one that became heavily popularized didn't do much. The whole class of drugs would get sort of poo-pooed,
Sure.
At the same time, Peniston was doing a lot of work with substance abuse and some trauma with the alpha theta protocol, which sounds similar, but it's fairly dramatically different where you're training up slow activity in the brain. And that produces this hypnagogic state, almost the relaxation response, the classical relaxation response feeling. That's what alpha theta training produces. And Peniston's had great success, and other clinicians using his stuff in training people with substance abuse issues in that particular protocol.
Now, hypnagogue, if I remember correctly, that's kind of the imagery that appears when you're falling asleep, when you're not quite in the dream state, but you're just you're drifting around.
It seems to be, clinically, a very healing state. The places where alpha theta neurofeedback works really well is in people that have a lot of anxiety and a lot of sort of maladaptive behaviors around the anxiety, like, for instance, substance abuse. And people that have, a desire to become more creative or access the sort of dreamy states in themselves. Actors will often do sequences of alpha theta neurofeedback to sort of wake up that creative part of their mind. But it's very different than the sort of beta training or SMR training that most neurofeedback is focused on. Another reason that it's a little difficult to adopt 10, 12 years ago is you couldn't really get into the space for less than $10,000. You needed a 2 or 3 channel, two channel EEG system and good software and a fast computer. And 10 years ago, that was about $10,000 out of your pocket. Nowadays, you can really get a clinical quality system for about $1,200. So the barrier to entry's plummeted fairly dramatically in the past decade.
So you said earlier that it's about 20 neurofeedback sessions in that you start to really see or feel like dramatic results. Is that where a plateau hits, or will continued use continue some sort of uptrend that's measurable?
You actually start noticing things, somewhere between 3 to 5 sessions in typically. And then somewhere around 12 to 20, people are often making good gains. Mm-hmm. And then 20 to 30 is often what it takes to resolve complex problems or to make permanent some of the gains that you're getting. I mean, it's like exercise. If you go to the gym once a week, you don't make much progress. You go 3 times a week, you make great progress. But then if you stop and you haven't gained some correction of your posture or some extra stability in your muscles, then you might not have all the gains preserved. Generally in ADHD and in even sort of peak performance and normative, individuals who just want to get a little extra edge, the gains are largely or mostly permanent. There's what we call savings, 6 months in, 12 months in. I've worked with normals, quote unquote, people trying to kind of get some peak performance. I've worked with elders trying to brighten their brain. And I've done a lot of work with children and adolescents who have attention issues, as well as adults with attention, minor attention issues. I mean, in spite of having a degree in cognitive neuroscience and doing a lot of work clinically with quote-unquote ADHD, I view attention as more of a continuum. And ADHD is just really at one end of that continuum and has some, again, evolutionary benefit. It's important in a primitive environment. So, I'm a little bit skeptical, and I always have been, about this diagnosis of quote-unquote ADHD. That being said, aspects of attention like vigilance and sustained attention and response inhibition are critical for willful, volitional human life. And definitely in a heads-down work environment, those things are assets.
So talk to me a little bit about some of the neurofeedback stuff that you're doing right now. It says that you're working in Beverly Hills with a company or a group called Alternatives that is using this for breaking of drug dependency.
Right. Addiction Alternatives is a company in Beverly Hills that is launching with a couple of folks. One is a very long time addiction specialist named he's known as the Habit Doc, Dr. Mark Kern. And then Dr. Adi Jaffe and I were at UCLA together, and he's an addiction specialist as well. And the three of us are, running this with a handful of other people, doing mindfulness, doing CBT, cognitive behavioral therapy. The piece that I'm bringing to the table is quantitative EEG and then neurofeedback. For substance abuse, I think that most folks tend to require around 30 sessions, maybe more if they have complex presentations. More stuff that's sort of physiologically outliers or, more complex complaints, not just anxiety and substance abuse and attention, maybe, some major depression or some PTSD, some other things that tend to come along with, the maladaptive coping strategies. So Addiction Alternatives is launched and, I'm the neurocognitive director there and bringing in the QEEG and neurofeedback. Sort of really enjoying getting back to the clinical focus after doing a PhD for 7 years. I'm really, really looking forward to getting my hands back on people and working with people outside of a research setting, and I'm enjoying the few clients I have already. I'm also working with another company about smart drugs, and he suggested that I give you a call.
It's a company called True Brain?
Indeed, TRU Brain.
TRU Brain, okay.
True Brain is a series of cognitive enhancing nutrients. It's a stack or a blend, we like to say, based around piracetam, which I'm sure your listeners are familiar with. Mm-hmm. And, we, the founder, Chris Thompson, and myself have looked at the nootropic field, which is really, full of what I call affectionately psychonauts, people that are experimenting on themselves, right? I'm sure your listeners are all nodding their heads and smiling.
Yeah, the mad scientists in the crowd are all like, yeah, that's me.
Exactly. And that's wonderful for us, for people that want to take some stuff and meditate or, look inward and see how it feels and try to figure out how to fine tune and hack their brains. But that's not really what I want to tell my mom to do. Hey, mom, buy a kilogram of piracetam from China. That's just not going to happen,
Right.
There's a lot of sites that pop up and then vanish. There's a lot of sites where you can't tell who's running it, or the certificates of authenticity or third-party testing certificates just aren't there. So the founder, Chris Thompson of TrueBrain, that really bothered him, and he saw sort of an opportunity, and he was excited about nootropics and other cognitive-enhancing supplements. And we started talking, and he developed this company, TrueBrain. And it's a piracetam-based blend. The website should be live, so you guys can go there now if you want and check out the blend. It's piracetam, and CDP choline is sort of the two, the classic racetam plus a choline formula that, most brain hackers go after. And then we added things like L-theanine, essential fatty acids, fish oils. I'm trying to think what else. Let me pull up my list here. Magnesium and tyrosine. And then we also have a boost of paramiracetam. We have 4 packets in there. So we thought, hey, let's make a company where we're actually transparent. We tell you who we are behind the company. We try to curate not only a stack for you, a blend, but we're going to try to curate some research. We're going to both, do annotated bibliographies of the existing research. One of the other scientists in the team is a guy named Christophe Michel, who's one of the few people who's done actual published research on normal humans and piracetam. So, Christophe, Chris, and myself, and a few other people, let's make this transparent. Let's, be skeptical scientists and look at the research and maybe do some more research ourselves as we have, revenue to support that. I'm an EEG scientist, so I could replicate or extend Christophe's research. And we want to make sure that we're not being some fly-by-night company, and we want to make it easy. It's a box that arrives every month with 20 packets in it, so you have all your work days covered. 20 days worth of packets. And then there's 4 more, I think, with paramiracetam for those, days we have an extra meeting or it's a long day or a weekend day where you're working.
I heard a rumor recently that racetams might become a controlled substance in the U.S. Have you heard anything about this?
I've heard that rumor, sure. I don't believe it. It's, controlled substance is really a schedule, right? Schedule 1 through 4 in the U.S. And scheduling is typically done for a couple different reasons. One is when a drug has adverse effects that are significant and risky. We all know piracetam actually doesn't have much in the way of risk. There's no LD50. It's impossible to give an animal enough piracetam for it to die, basically. The LD50 of piracetam is higher than salt. I mean, it's really extremely safe. The effects are also subtle. The other reason things are scheduled is when they're drugs of abuse, when people seek them and crime grows up around them. You don't get high off of piracetam. There's no euphoria. There's no drug seeking. And there's also none of the other aspect of drugs of abuse, which is addiction, meaning tolerance and withdrawal is the 2 components of addiction. So you don't get addicted to piracetam. If anything, the racetams work, they're subtle, but they also work better the longer you take them. There are acute effects that show up in the first few days often, but then there's sort of chronic effects that start to show up. From what folks have told me, it's around 3 to 6 weeks, which really does, it jives with new neuron growth and neuron formation. It takes about 5 weeks for neurons to be born, travel to the place in the brain where they're going to live, and turn into the kind of cell they're going to be, making friends along the way.
We spoke about the racetams pretty extensively a few weeks ago with Phil Mikens over at Anti-Aging Systems in the UK. He was saying that oftentimes, actually with piracetam in particular, it's best to sort of start at what would sort of be considered maybe a higher dose and then wean yourself back.
Funny you should ask. This is an idea that Chris came up with, and I probably would have suggested it had he not, because it's a great idea. We have a 20 days worth of packets in our TrueBrain box, and what we've done is in the first 10 days in your first box, we're giving you twice as much piracetam. So it's 4.8 grams a day for the first 10 days, and then we drop you to 2.4 grams after that a day. And then, your second, third, and fourth box, we're just maintaining at 2.4. So, there is some intra-individual variability in response to racetams, but piracetam is sort of the safest and best studied. And I think that 4.8 will kick off the experience, as it were, for almost everyone within a few days. And then, they should have good maintenance and long-term effects at 2.4. I talk to people that continue to get interesting new experiences, subtle memory restore, or, interesting cognitive experiences, even months or years later. So I think that the process of what's happening continues to unfold on something like piracetam. It's helping your brain reorganize. Christoph's paper on EEG and single dose showed EEG microstate differences, organizational differences in complex brainwave patterns with a single dose. Wow. So if it reorganizes your brainwaves, the brain's a pattern matching machine. Its job, its love is to change its wiring and its activity based on what it observes and on what's pushing on it. So if a single dose of this stuff changes the complexity of your brain and you're taking it every day, chances are extremely good that it's doing something to change the organization and complexity of your brain itself long term, because the brain will pick up patterns it's exposed to and re-implement them and be efficient. As someone who's involved with a supplement, I don't make any claims for it. We don't really know. We have a sense it's very, very safe. And subjectively, I love the way it feels. I mean, the stack that True Brain Blend is based upon is pretty much what I take every day. So, it's something I've been taking for a couple of years, and I like the effects, and it's what I tell people to take pretty much when they ask me what they should take. So we're really trying to make this, a lot of critical thinkers who are, if we do research, it won't just be, here are some surveys. It'll be, physiology, pre and post, or off the stack and on the stack. If I give folks, behavioral tests, it won't be a checklist. It'll be a test of performance, a continuous performance task, or a go, no go, or some, classical cognitive neuroscience test that's well established and well validated, so we actually know what it means when it changes. One of the issues I have with brain fitness these days is that it's almost all oriented towards cognitive training, gamification of training. And to some extent, all the games out there are simply putting window dressing on the classical neuropsych and neurocognitive battery of tests. There's not a lot of IP there, intellectual property there, I don't believe. And there's also kind of an issue that training on a game doesn't necessarily transfer to non-game contexts. There's a lot of recent press about that with things like the dual NBAC. And so you have to consider when a cognitive training test is changing, is it changing because you are improving? Is it changing because the test has a very large practice effect and it's actually not very valid between test administrations? And so you want to find a test that has a very quick plateau. The practice effect goes away. I'm always suspicious of tests that, as long as you practice, you can keep getting better. That's probably not you getting better as much as your score sliding along your, gaming the test itself.
Yeah.
So, we, True Brain will probably partner with or build some cognitive tests. But we really think that one of the pieces that's missing in cognitive fitness, brain fitness, is the nutrition piece. When you do bodybuilding and when you go to see your personal trainer for your gym, he tells you what exercise or she tells you what exercise to do. But she also tells you, what you're eating that's wrong or what you might want to eat that's potentially better to support your new bodybuilding strategy. And I haven't seen the same sort of, sensible, conservative approach to brain fitness. It's more like, let's find the really cool and unresearched research chemical and try that. Or it's, let's do some cognitive fitness training, which, we're not even sure transfers.
So thank you very, very much to Andrew Hill for that interview and all the information about both neurofeedback and his True Brain supplement. Having gone to his website and sort of looked through the ingredients list for True Brain, it really is a pretty solid starter kit for what one would sort of want if you're starting on nootropics from ground zero. It's got a bunch of stuff in it that pretty much nobody disagrees. Thinks any of these things are bad ideas. Everybody agrees that piracetam is helpful and safe. Everybody agrees that omega-3s are helpful and safe, that a choline group, that magnesium. These are all sort of absolutely by the book. Well, they're all supplements. None of them are prescription drugs. So it's kind of exactly the mix that you would want if you want to avoid having, say, a medicine cabinet that looks like mine, where every morning there's 14 or 15 different bottles of pills staring at you, and you need to go through each one individually and dose yourself out. So yeah, anyway, kudos to him for putting that together. And I also spoke with Dr. Hill afterwards, and he's going to get us hooked up sort of as a Smart Drug Smarts community. We're going to have a discount coupon code that if anybody wants to buy TrueBrain, there's going to be a coupon code that I'll have within a day or two, and we'll put up on the website for this podcast episode that will allow people to get a 15% discount. I'm not actually going to be taking any commission off this myself, but I am curious as sort of what sort of collective buying power we have as a group. So I did ask for a unique coupon code to the Smart Drug Smarts community so we can kind of see how much buying, if any, goes on through us. I think it would be pretty cool to know about that for the future. See if we can possibly throw our collective purchasing weight around with other nootropic suppliers as well. So anyway, we'll see what happens there. But yeah, that'll be on the website within a couple of days here. Now, shifting gears radically from drugs that everybody agrees are safe and useful to ones that people have wildly divergent opinions on, let's go to the ruthless listener retention gimmick.
Smart Drug Smarts, ruthless listener retention gimmick.
So Professor David Nutt of Imperial College London is at it again. If you haven't heard of Professor David Nutt, he was rather famously fired in 2009, or sacked as they say in Britain, from his position as the chairman of the Advisory Council on the Misuse of Drugs after he repeatedly clashed with the British government on their policy on various, what are considered party drugs that he said have legitimate medical uses if only the government would be a little bit more lax in their policies and let scientists study them enough to identify and quantify what those medical uses might be. The government didn't like that so much, and they said, heave ho, buddy, you're out of here. But he still has his post at the Imperial College London, where he is trying to get permission right now to study the effectiveness of psilocybin, which is the magical ingredient within magical mushrooms that basically gives it its psychotropic properties, and use that as an antidepressive. He says that psilocybin is known to switch off a part of the brain called the anterior cingulate cortex. It's this piece of the brain that is known to be hyperactive in individuals suffering from severe depression. And in tests on healthy individuals, healthy volunteers, it was found that psilocybin had a profound effect on happiness, leaving people feeling happier weeks and weeks after they'd taken the drug, long after the psilocybin itself had left their system. So he says there's plenty of reason to believe that psilocybin could be a very, very effective and relatively inexpensive treatment for people suffering from severe depression, something which costs the British public, hundreds of millions of dollars annually, both in treatments and in lost work time and stuff like that, and not to mention people feeling miserable when they're severely depressed. So there's all sorts of reasons, both financial and moral and ethical and all that stuff, why this should be a legitimate thing for him to study, but that right now, basically, he's not able to. He only needs a couple $100s worth of mushrooms to run this study, but he said it would cost him hundreds of thousands of dollars, or British pounds in this case, to fight the legal battle necessary to force the government to let him run this study in the first place. So he's making a big ruckus trying to get this issue as public as possible to shame the British government into backing down on this and letting him run his study. And of course, we stamp our feet and knock on wooden tables and whatever it is they do to show support in Britain and hope that Dr. Nutt is successful.
Smart Drug Smarts, the podcast so smart, we have smart in our title twice.
Okay, so that is the whole episode now. Thank you very much for hanging out with us till the end. Very much appreciated. Appreciate also those of you who let your friends and people like that know about the podcast. We've been getting an increasing amount of traffic, so I can only assume that somebody out there is talking. So you do not need to follow either of the first two rules of Fight Club when it comes to Smart Drug Smarts. Definitely do tell your friends. Want to put out a big thank you to Robert Kolker of New York Magazine. He recently wrote an article about modafinil, which mentioned Smart Drug Smarts by name, and apparently led to a bunch of new web traffic and probably people finding out about the podcast from that. If you want to follow in Robert's heroic footsteps, tell your friends, tell your enemies, write smartdrugsmarts.com above your favorite urinal, whatever you think is going to work. Definitely much appreciated. I will see you next week at approximately the same time at exactly the same podcast, and hope you're having a great week in between.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization.